Welcome to this week's discussion on integrating effective technology and effective assessment into the secondary math classroom. Um, Cheers. We can do that while teaching in quarantine. At any rate, okay, so let's talk about integrating technology and assessment effectively. I'm going to tease these out separately, but then I'm going to unite them together because one does impact the other. So in terms of technology, the thrust of the chapter really was about integrating technology um, at the aim of promoting mathematical reasoning and sense making in your students. We don't want to integrate it for the sake of integrating technology on its own. Hi everyone, welcome to this week's discussion on integrating technology and assessment effectively into the secondary math classroom. So these are two separate topics, but really they can be quite integral to one another, and I'll talk about them separately, but then I'll unite them together in the areas where they overlap. So on your screen, you have a list of the goals of what effective technology use is supposed to produce in the math classroom. Ultimately, the goal is to utilize technology in order to promote mathematical reasoning and sense making among your students. You don't want to integrate technology just for the sake of integrating technology. You know, many classrooms are equipped with smart boards. Many are going to be one-to-one in terms of having iPads. You really want to be thoughtful about how you're utilizing that technology and make sure that it's at the service of promoting students' conceptual understanding. Does that mean that you shouldn't use it in order to do some perhaps drilling of students? No, you can do that because we know procedural fluency is important to conceptual understanding, but you want to leverage it primarily in order to help students grow in their conceptual understanding, for them to be able to articulate what they're doing, why they're doing it, to be able to compare and contrast methods, and for them to be able to look at a particular problem through a more scrupulous and analytical lens, in a way that if they had to do problems by hand in order to achieve whatever your aim is, it would be too time consuming for them to explore. Really, the goal should be to utilize technology at the service of moving students out of that concrete level of thinking. In the textbook, it said that 2/3 of high school juniors and seniors are still functioning at a concrete level of thinking. And that really is shocking when you think about it. Probably most of you were not, because you're going into math, you had those aha moments where you saw connections probably before a lot of your classmates did. And the problem is you have a lot of students functioning at that lower level, but being taught at a higher level, and there's that disconnect. So technology can really help bridge that gap for students. Let's look at a couple tools that enable you to do that. And Amelia mentioned one in one of her posts last week, which was excellent. She mentioned Desmos. I'm a huge fan of Desmos, and Desmos really has two tools. Desmos.com, which is a free graphing calculator that has many capabilities that are very streamlined and easy to use. Actually, much easier to use than your handheld graphing calculator. And then there's teacher.desmos.com. Teacher.desmos.com allows you to create a technology-based activity for your entire class to do that you can evaluate in real time as they're completing it, and they can also see each other's responses, so it builds learner community. And you can embed and integrate the high-powered Desmos Calculator into the slides that you create for on teacher.desmos.com in order to make your lesson all the more challenging or to enhance the analytical nature of it. But let's look at a particular way that you could harness technology to achieve the very things that we're mentioning, particularly increasing student conceptual understanding in an efficient way that's not too time consuming. One topic that usually takes a while to explore, particularly if you're doing it by hand or even if you're just using a standard graphing calculator, is quadratic functions, and how changing some of the different parameters in it affect the overall look of the graph that you create. But I'm going to go ahead and I'm going to go into the Desmos calculator first. Here's our Desmos calculator. This is just a parabola slider, and it's one of the apps within the Desmos calculator, and it pulls up a standard parabola, and then underneath it, it has what would be our parent function showing, okay, what would happen if we had a coefficient out here called a, and then one inside here called h, and then one outside here called x. What happens to this standard parent function of x squared if we manipulate these different constants? And students can see, look what happens to my function versus the parent function if I change a, the coefficient on the outside. Ooh, an entire flip happened. What happens if I change the h? Uh-oh, I'm seeing my x value of the vertex shift, either left or right. Okay, let's look and see what happens with k. Again, seeing a shift of the vertex up or down. Doing this by hand would be tedious. Even entering multiple equations in your calculator would take quite a long time. This took barely any time for students to have some big revelations. And what you could do is you could ask your students, either in small groups, to do this and then to reply to questions like those I have on the screen. What impact does changing a have on the parabola? What impact does changing k have on the parabola? What impact does changing h have on the parabola? And you could even ask them, to expand what happens if you change it to positive or negative. These could also be assigned in groups where you ask the students to then present in small little groups what happens and to illustrate it as well. This helps the students with defending their answers and really just using mathematical language, which is so important in the math classroom because that's generally something that is not done enough. And so students feel intimidated to speak using academic language in mathematics. This is one way that you could employ technology, but also at the service of assessing student understanding, which is how these two topics overlap. But you could also utilize that teacher.desmos.com, and I wanted to pull up one that dealt with parabolas and quadratic functions. You're looking at one on the slide that's already been created. So there's a whole host of activities within teacher.desmos.com that other teachers have created and then shared with the learning community. And I know some of you have created your own activities and you've probably made them public too so that others can utilize them, which is awesome because we don't always need to reinvent the wheel and we can save time if other teachers have already invested. You can also just copy certain slides within an already created teacher.desmos.com activity and then utilize them in yours. But this one asks the same type of questions that I just asked, but within the teacher.desmos. And I love this because it asks a question like this. If we change the -3 to a 2 in the equation, so the equation is down here. You can't totally see it, but it says -2 times x minus 3 all squared plus 1. What would happen to the graph? So the student could, go ahead and manipulate that on here to see what happens when they move. They could also come back and do it on the slider if they would like, but then they have to articulate it here and share with the class. As soon as they share with the class, their answer pops up, all the other students' answers pop up, so they're able to compare their response to other students' work. And peer assessment, having another student assess your work or you assessing your answer to another student's work, helps you to determine A, what is high quality work, and B, what is the right answer. So students are learning through that whole process what is right and what is wrong, and what also makes a truly high quality answer. And moving on to assessment, that is one of the big goals of effective assessment. In fact, that's number 2 up here, helping students learn to assess and recognize high quality in their own work. A lot of times I'll give exemplars, provide this as examples for students with various assessments that I have. And the reason I do that is simply so students can see an example of high quality and use it as a baseline to judge their own work. Doesn't mean you want them to produce something that's not unique and just like someone else's, but a lot of times we don't know unless we see. So I think that that's important in the math class, that you provide them with what a high quality answer might be. Or when a student has an answer that's good but could use a little bit more support, asking another fellow student to say, hey, what John offered was great, but could you expand upon that more to support it? And then asking someone else to do that. And then we're working as a community of learners to establish what would be the best answer. And in real time, students are realizing that. But with respect to assessment, while that's one of the most important goals from the student end, helping them to self-assess, you're embedding instruction in assessment throughout, you're embedding assessment throughout your instruction in order to make adjustments continually in that instruction to best serve the needs of your students and to serve them in deepening their conceptual understanding. We've talked about how asking high quality questions throughout, how important that is to you understanding what students know. And that's one form of assessment. But asking them to represent problems in multiple ways. So you're able to see if they've not just learned one particular strategy, but if they're growing in their ability to adapt their reasoning, and if they have a broader conceptual understanding of a particular concept. Also asking the students to compare and contrast one concept to another, like comparing and contrasting substitution with linear elimination. How are they the same? How are they different? Why do they produce the same answer? So those are different things that help get students thinking and also help them demonstrate command of the concept in the language that they're using. Also asking students to respond in math journals or on exit slips. We know that students often struggle with intimidation to speak in math class, and continuing to ask them to do so will help them become comfortable, but in the beginning, it's very difficult. It's like pulling teeth to get them to want to talk. But students are much more apt and comfortable with writing because they don't feel like they're put on public display. But that gives you an opportunity to gauge their understanding, probably much better than asking them to articulate in groups or individually or out loud, because that intimidation is removed. But when you do those exit slips, it's so important that it's not just based on procedural fluency, though there is a place for that and it is important. You do want to, again, make the goal conceptual understanding. So asking questions like, can you justify your reasoning in your steps? Can you explain? Those are very important. So you just want to make sure that you put an emphasis on integrating those. So those are the major goals of technology and assessment. I'm going to type my 2 questions regarding both of those elements into Blackboard. I hope you're all doing well, hanging in there. I'm doing okay. This new switch to homeschooling has been humbling, but also very good considering it's Lent. So pray for me and I'll pray for you, and cheers.